So, we're going to look at multiplication and division using significant figures. And we say Sig Figs because I'm lazy, and that's okay. All right, general rule is going to be, if I have something like this, do this on the calculator please for me. If I have 3.016 times 12 times 8.940, can you do that on the calculator for me? And then one person, raise your hand and give me the answer once you have it on the calculator. Yes, Max. What do you got? 323.55. Yep. 648. All right, so some huge number. Max is wrong, but no, I'm just kidding. So 323.55643. That's huge. It's not following the rules of significant figures because this is what the rule is about. You have to look for multiplication or division. A lot of people use it for all, including addition and subtraction, and that's where you're going to be wrong. This is just multiplication and division. You have to identify the number of significant digits in each. How many here are significant? 4. There are 4 significant, including the trapped 0. 12 has how many? 2. Well, I shouldn't. Well, I'm going to circle them. I don't want to think they're divisions. How many here?
3.
There's actually 4 because there's a trailing 0, but there's a decimal. So we got 4. The rule for multiplication and division with Sig Figs is going to be, your answer will be in the lowest Sig Fig number that was used. 2 in this case. This one right here with 2 tells me that my answer is only going to show 2 Sig Figs. How can I get my answer to be close to this and only show 2 Sig Figs? Yes, Marcus.
It'd be 3.23.
Okay, if we say 3.23, the only problem is these numbers are very different from one another. And 3.23 actually shows 3 Sig Figs. So we'll be off with that. I'll try to edit that later. Yep. 32. 32. All right, so 32. It used to be 323 point all that. What do you want? You're saying 320? All right. I will tell you that's the correct one. They both show 2 significant figures, but there's a big difference between 323 and 32. If I owe you $323 and I only give you $32, you're not happy. In reality, you can still do 2 Sig Figs and still be in the same place value. 323, well, 320 is what we're going to use. When you want significant figures, in this case it was 2. You go to the 2 numbers, then you look at the third and ask, does this number round up? It has to be 5 or above, so it does not. So therefore, the 2 is not going to get rounded, and this will then become a 0. 320 is correct. Good job. Okay? So once again, we cared about the number of Sig Figs. Let's try another one, please. Let's see. Let's do 500 times 32.69 times 5.36. This time I only want the final answer. No, actually, no. Give me the whole answer and then give me the final answer. Okay? When someone has it. Go ahead, Max.
16,350.36.
Oh, wait. Sorry, 16,350.36? Okay. So, that's what the calculator shows you, but according to the rules of significant figures, Max, what would it be? What do you think? What's your final answer going to be? All right, first you're saying only one significant figure, and I'm going to tell you that is true. One significant figure. This one shows 4, that shows 3. I need to take this number and only show one significant figure. Yep. you're saying 20,000. And I'm going to say you're absolutely right. Reason being, here's the one figure. Does the 6 round that up? Yes, it does. Here's your 2. And then all of these can be zeros and still show just one significant figure. Yes.
I didn't get 16. Yes.
Oh. Okay. All right, well, first let's do this. Let's just assume this was right. That's how you would do it. Okay. Now what do we have? Give me the real number. 876. 87609.2. All right. What would you do for that? What's the final answer?
9,000.
Not 9,000. It's just 90,000. Okay? Here's your one sig fig that you have to use. The 7 will round it up. The rest will be zeros. If you just say 9, you're way off. Because if you owe me this huge amount of money and you give me $9, that's not good for one of us. Okay? So that's multiplication. The same thing applies for division. All right? Now we have addition and subtraction. Let's go to that. So, we will have, well, actually, I usually say subtraction then addition, and there's a reason. Subtraction and addition with sig figs. All right. So we get that, and what I'm going to tell you is I use acronyms all the time. That's how I got through college. That's how I got through life. The acronym I use that helps me is SAP. Subtraction, addition, the P is for place value. It's all about the place value. Whether it's tens, hundreds, place value is important. Not the number of significant figures in each number being used. That's multiplication and division. And that's where people mess up. Subtraction and addition, it's all about place value. Here's my example. If I have 3.67, and I'm going to add 7.0, and I'm going to add 13.659. Can you do all that, please? Tell me what you get from your calculator, and then I'll show you what the true answer is with significant figures. What you tend to do is you do the whole problem out, and then you use the rule for significant figures. That's probably the easiest way with the calculator. All right. Matt, what do you have? 24.329. Okay, good. Now the rule will be this. It's all about place value. You're going to go from left to right, starting from the largest place value, working your way down. You're going to stop at the place value, at the last place value that they all have in common. For example, they all have the ones. No problem. I go here. They all have tenths. They don't all have hundreds. It's missing right here. I have to stop at this one. My answer will be in tenths. So therefore, tenths is right here in my answer. I look to the number after it and ask, will it round off? Will 2 round the 3 up? No. The correct answer that I expect on a quiz, when we use significant figures, it will be 24.3. You have instruments that can read, in this case, this number here, the instrument read up to the hundredths place. That's fine. You have an instrument, the bottom number, the instrument read to the thousandths place. Good. But you had another reading, it was limited to only the tenths place. It didn't go any further, so this limits how accurate you're going to be, because it doesn't have anything further. So you can only go to the least accurate, okay? And in this case, it's the tenths, so my answer can only be in tenths. Yep.
None in the first one.
That's okay, but we go to the left. So once we hit all the numbers, we start looking and working our way down for place value. Okay, Max, you hit the phone. Good, I'm sorry.
There's nothing in the one.
In other words, you're saying like right here? Yeah, there's nothing in this place here, in this place here, but you will encounter some numbers. It's when the numbers stop. And they stop. This is the last one that we're going to have, where they all have it in common, and then no more, so I have to stop. But you do the whole problem out, then you resolve it according to Sig Figs.
What if you just have like 7 without the point out? Does that still make a difference?
No, it does make a difference. The difference between 7 in this spot and 7.0, the 0.0 tells me I have an instrument that I'm recording with that can record up to the tenths, versus I have an instrument that can only record to ones. Okay? There is more accuracy there, okay, or precision there, versus that one. So we do have to go all the way to it. If it didn't have a 0 at all right there, then you'd have to stop at the ones, because that's where they all end. They would all end in what's in common. Okay, does that make sense? Good. Head nods help.